Good morning, everybody, and welcome to today's webinar on Spice Up Your Layouts with Autodesk Factory Design Utilities. Before we get started with the webinar, please take a moment to review our safe harbor statement regarding the information we are about to share with you. Also, please note that we have a lucky draw at the end of this, we have a set of questions that we would like you to answer at the end of this session, and out of all the people who are going to answer these questions, we are going to do a lucky draw and announce winners by the 18th of December. So please, requesting you all to stay throughout till the end and share your please answer the poll questions, and also you'll be receiving a link from our team which you need to answer with your feedback. So with this, let's get started. So the topic for today is spice up your layouts with Autodesk Factory Design Utilities. And my name is Sanjeev Ghosh. I am a senior technical specialist for the design and manufacturing vertical of Autodesk. So why are we essentially talking about factory design utilities? Is because there are some radical changes happening in the way the things are designed, and we often hear from our customers, they are looking for ways to innovate. However, they struggle to find the time. Our customers and you and your consumers are looking for better performance, which requires a complete understanding of how your designs operate before they are built. Also, you need to know, are you getting the most out of your machines? What are you doing to ensure that there are no bottlenecks in your process? So what are some of the ways to win more business? We are in business to help our customers, but to sustain ourselves, we need to keep on continuously winning more and more business. So these are some of the things that we are trying to solve with the Autodesk Product Design and Manufacturing Collection. What if I told you Autodesk offers a solution that spans across design and manufacturing? It includes the tools you need to design, simulate, analyze dimension tolerances, nesting, CAM, and even do factory layout. And all the data is stored and managed in a secure project. Best of all, the collection is available as a single affordable subscription called the Product Design and Manufacturing Collection. And it contains some very interesting and powerful tools that help you to not only conceptualize your design, but completely engineer your product and take it through to all stages, and finally to manufacturing and producing it. It's this collection of technologies that enables you to connect on a single design platform, automate processes, and accelerate production. By innovate, I mean that you get the time for more innovation and take advantage of the tools that are purpose-built to have a positive impact on the way you design and make products. By connect, I mean run your entire product development process on a single platform, powered by a professional grade 3D solid modeling, simulation, documentation, and multi-axis CAM tool. Finally, being able to automate, leverage data, artificial intelligence, and cloud technology to reduce iterations, optimize tolerances, solve complex engineering problems, and quickly create production-ready designs. Now, you probably have AutoCAD, I assume, and if not, I'm sure you would have heard of AutoCAD. AutoCAD has been in manufacturing for over 30 years now. But you may not know that Autodesk has an entire portfolio of capabilities used in manufacturing. So from layout to building design to designing jigs and fixtures, be it MEP, ducting, you name it, and we have all tools and tool sets that enable you to complete your product design and take it to manufacturing. Today we are going to talk about factory design utilities. Factory design utilities is one of the tools which enable you to clearly communicate your design intent to various stakeholders. Now, well, AutoCAD is a good tool, but factory design utilities has been purpose built to address challenges facing manufacturers today, namely more frequent changeovers and need for flexible manufacturing, shorter timelines, and higher manufacturing complexity. So these are some of the tools or some of the areas which we intend to address with factory design utilities. As you know, your production is always in flux, responding to changes in your business. These changes are commonly grouped into these items. There is the new product introduction, there are changes in demand, and I'm sure everyone today is talking about cost cutting initiatives and quality improvement projects. And adapting to and implementing change provides a significant competitive edge to you. Now, when it comes to a factory, we, of course, the product design is the key, and the people who design a product are the ones who define the strategy on what the company should do and produce. But this product that is designed by a set of designers and engineers needs to be manufactured, and there are lots of other people such as these who are in touch with the product data and have to work with the product data and have to take decisions on the manufacturing of that product in a factory. So if a typical factory has a product design cell, a larger part of it is occupied by people who go on to manufacture the product designed by the product designers. So we may call them production. They are manufacturing engineers, facility operations, machinists, and more. Now let's consider an example. AutoCAD is perhaps the industry standard for layout tools today. It is a very powerful tool for planning, but it does not represent the full manufacturing environment. Real production environments are much more complex. Errors are typically introduced when information is missing, like from vertical dimension, or what needs to be moved or to be removed, or how items will be moved into position. Factory Solutions has the factory design utilities has solutions for all of these areas. So looking at a layout which is typically a 2D, of course, it's a good way of representing, documenting, taking a printout and filing it for the purpose of complying to certain industry standards. But when it comes to conveying this information, and when a real factory looks something like this, it's all 3D. There are elements at all levels, and that may not be clearly represented in a 2D drawing and interpreted correctly by all the stakeholders. So this is where we introduce to you the factory design utilities. And here you can see factory design utilities provides a rich set of workflows that can be used for implementing changes in your factory, from starting right from defining a process. So process definition is not just placing a few blocks in AutoCAD on a space given to you, but it's taking some important decisions about how you want to arrange your equipment. How do you define your process? What is the capacity of a machine that you want to use for a certain part of a process, and so on. Layout planning comes a little later. Once you have decided on your process, defined capacities, defined all your sizes of your machine and so on, that is when the real layout starts getting done in AutoCAD. But before that, a lot of these decision making activities do happen. And finally, once a layout is complete, it's very important to convey that design to various stakeholders. And as I said, just having a 2D layout on a flat surface may not be good enough to address certain areas. One of them is, of course, communication and being able to review your design correctly. And finally, once we are done with our design and we have communicated and everyone has agreed to the design of the layout, there is the need for change management as well. So being able to capture and control documentation, maintain versions of your document correctly is also very important, and that is what Factory Design Utilities helps you do. So let's start with the first element, which is being able to define a process. This is done using a tool known as Process Analysis 360, which is part of the product design and manufacturing collection connected to the Factory Design Utilities. It helps you to quickly identify bottlenecks. It helps you to study unplanned downtime and improve your processes by iterating before you actually implement the changes on the shop floor. So you can test out various scenarios of your production. So let's quickly take a look at a small example out here. So the Process Analysis 360 is Autodesk Process Analysis is a tool that helps you define your process, and either you can create your process right from scratch or take information that you have already articulated in a spreadsheet. Now here I'm able to create a product. I'm going to define how much of the product I need to manufacture at what rate, what are the equipment that go into manufacturing this product, right from storing it in bins to doing an assembly, doing various manufacturing processes, and figuring out how much time the entire process is going to take to really manufacture this product. Each process can be very clearly articulated by defining and making changes. So I can really make changes right here without having to figure out those changes after I have really purchased a machine. And then since I need to communicate this information to other stakeholders as well, I can generate a very nice report that can help you to convey the findings of your process analysis. And this same output can then be outputted and taken into AutoCAD to do your layout design. Now let's pause here for a moment and let's look at things the way we would do it in reality. So let me take you directly to the software. And let's quickly switch gears and let me open up my AutoCAD, okay, where I am going to talk about the process and show you things the way they are supposed to be done. Now this is AutoCAD architecture, or it can be just AutoCAD. But right now I have opened existing layout which was maintained by my factory planning team, and they are also tasked with improving the process and making changes to the layout. So once I have gone through the stages of process analysis, now it is actually the time to look at how the physical layout is done. And of course, since we discussed earlier that AutoCAD is perhaps one of the tools that helps us do a very quick conceptual layout. So I'm going to start with AutoCAD. I'm not going to jump directly into a nice looking 3D tool, but I'm very convenient. I am very conversant with AutoCAD, and I find AutoCAD the most convenient tool to start creating my layouts. Now, what I have to do here is, or the task that has been given to me is the task of creating this new cell. Okay, so as you see, I have marked an area called the new cell, and I am right now in AutoCAD, and this is my new cell. Now, one is, I have a very large factory, and this is perhaps a very small layout, but my real layout can comprise many meters and a very large area, comprising many buildings and so on. So I can actually maintain one single drawing, or using the capability of AutoCAD to be able to break up a drawing into smaller elements, I can make my drawing more performance friendly. So here I'm going to make use of a similar method where I'm not going to start creating my layout of this new cell in this master layout. Rather, I'm going to take this out. So when I click this layout, you see I get a new toolbar, which is a contextual toolbar for external references, which means that this file or this layout is an external file that has been embedded in my current layout. So I'm going to go ahead and open this reference. So great, I could do that very nicely. So no big deal. I could open that, and this is something which is not specifically a feature of Factory Design Utilities, but this is a feature that has been there in AutoCAD since a very long time. So people who have been creating layouts frequently use the capability of creating external references and storing parts of a layout as separate drawing files. Now, if I go on to my Windows Explorer, I'll see that this is also maintained as a separate drawing file called the new cell. Now, some of the things that I'm looking at here on my screen, and which are different from the AutoCAD that I might be using, is this asset browser on towards my right, and the layout browser on my left. Of course, I can place these panels anywhere I choose to. This is the layout I prefer to use. And where do I get these palettes from? I get these palettes from the new factory menu that you see on the top here. And towards the end, I'm going to also talk about how do you get this factory menu out here. Okay, so if you have simple AutoCAD or AutoCAD architecture or mechanical, you may not have seen this factory tab. So it needs to be brought here by installing the Factory Design Utilities, which needs to be downloaded from your Autodesk account. Once you have done this, you get a host of palettes which include the asset browser, which also include things such as the layout browser and things like material flow and factory properties. So we are going to look at a few of them today, starting with the asset browser here on the right hand side. So asset browser, as perhaps as the name suggests, is a library of assets. Now, what are these assets for? These are assets of equipment that goes into a layout. If it is a factory layout, these will be assets that are relevant to my factory. There will be equipment, there will be conveyors, fencing, elements of a building, columns, various things that comprise a factory layout. If I'm doing a very quick PCB design, for example, my assets can be elements of an electronic circuit. But right now, we are going to look at factory design, and let's see what we have. So we have this folder called the system assets. Okay, And the system assets is something that is pre-populated. It comes with the software when you install Factory Design Utilities. And there are additional things that are there which are essentially not installed, because when we give you the software, we would have updated it with everything that was latest at that point in time. But when you are so as you use the software, and also parallelly at Autodesk, we continue to add more and more assets. So the way we deliver them to you is through this the means of this cloud. So you see a symbol out here on the top which says cloud assets are enabled, which means that I'm connected to the internet and I can get more assets. So if you see some of the assets out here have a symbol on the top right hand side corner which is not green, and one has this asset here has a green tick. So between the two assets, this is the one that is available on the cloud, and which I can download for use in my library. And this is the one which I have already downloaded. So we continue to deliver newer assets to you because we are continually adding newer assets to our system assets library. Having said that, we may not have everything that you need for a factory, and we also give you the ability to create your own assets. And for this exercise, what I am going to do is I have created a favorites folder here. Rather, I have not created a favorites folder. A favorite folder already exists in the asset browser, and I have created a folder by the name of training, in which I have saved a few assets that I want to use. So the point being that there will be thousands of assets, and one is you can always search for an asset by going to the search button here. For example, if I want to search, let's say, robot, and I do a search, it will populate a host of things for me to use, and I may not be sure which one in particular I want to use. So what I intend to do is the assets that I use very frequently, something that I store in my favorites. So I don't need to really search for them again and again, but I can quickly pull them up from my favorites folder. So let's complete our design now. Okay, and this is purely an AutoCAD workflow which is similar to the existing practice of creating a library of block elements and dragging and dropping and placing blocks in a drawing. So these assets here are, when I place them out here, so let's start that. When I place them, they are pure AutoCAD blocks. There is nothing 3D about it, because I am currently in AutoCAD and I want to do things very quickly. So I am in AutoCAD and I want to leverage AutoCAD capabilities of being fast and agile. So that's what I am doing here. I'm quickly placing assets out here, and just like placing blocks, so I'm going to place various objects out here. Also, let me continue to place more assets. And I can obviously move assets exactly the way I can do it in plain AutoCAD, and I could do it. So this is just exactly the replication of the workflow that we follow in AutoCAD. And I'm just I just did a copy and paste, and I could quickly duplicate an asset. This is great. I could quickly populate an asset, and fine. So this is what I do in AutoCAD. I quickly take blocks of objects and quickly populate my layout. But we want to see something very interesting now is, I want to place, so if I click on this object here, this is nothing but a polyline which has been given a thickness. Okay, so it's a regular polyline, and I see these two small circles. These represent points where I need to place a fence. So let me search for a fence asset. Now I came across a lot of assets here. I can obviously drag and drop and place the assets exactly the way I did it for these earlier ones that I placed. But here I'm going to use a very interesting kind of an asset. Okay, so assets such as a fence, a wall, or a conveyor chain, a series of conveyors, okay, can be represented by a line or a polyline in a 2D layout. And but in actual, in a physical reality, it's not a line or a single object. The fence is broken up into smaller elements and joined together. Same way, if it's a conveyor, and if I choose to represent a very long conveyor by a line, it is not manufactured as a single piece. It's a set of conveyor pieces that are joined together to form the conveyor chain. So here we have an asset type known as a chain. One is a regular fence asset or a chained asset, as in this. And I'm going to use this to draw an asset from point A to point B. So let me do it again. So I'm going to draw it from right from this point here to this point. So this is my conveyor, and I want to convert this polyline here into a fence asset. So I double click and invoke the chain fence command, and I right click and say select an existing polyline. And I did that, and I just completed it. And let me save this drawing. Now, great, I have completed my layout. But as I said, this is good, and this is a very simple layout. Maybe this is good enough to convey the intent of my layout, but I want to really convey how this really looks physically. And there are objects that are not, everything is not on the floor in a layout. There are things that are supposed to be placed on a pedestal, on a raised surface. So even if I show something placed on the top of this platform here, for a 2D element, it hardly makes a difference. I cannot represent it very clearly. So I need to do these steps, convey my design, communicate my design to right stakeholders who might not, everyone might not be able to clearly interpret a 2D drawing. So how am I going to do that? Let me close a few things that I was doing before this. And what you see on screen right now is Autodesk Inventor. So before I get started, let me quickly make a few changes. I want to sort of ensure that the templates that I'm using are metric. So I just had a look at that, and that's all fine. And I want to now take that layout in AutoCAD to Inventor and sort of create a quick 3D. How can I do that? There are many ways. I can just copy paste this as a layout, as a drawing object in AutoCAD sketch, but then that doesn't give me a layout. Essentially, that's not what I intend to do. I have a better workflow than that, and I can directly say open this layout in Inventor right from AutoCAD. So I click on this, and I wait for a few steps to complete. So this is an interoperable workflow between AutoCAD and Inventor. And Inventor, essentially, many of you may know, is our professional grade 3D modeling software used for product design. But here we are going to look at a factory design workflow right out of Inventor. So it's a automatic workflow. It automatically takes you to Inventor from AutoCAD. And in Inventor, what really happened is it opened up a new layout file, layout assembly. So layout assembly is different from a normal mechanical 3D assembly, where we have various things that are not there in a regular 3D assembly, such as what you see on the screen is a floor. And this is a floor where we will be looking at various assets being placed. So this is the same AutoCAD layout that is coming up on screen in Inventor. And the same objects that we placed in AutoCAD have been converted to their respective 3D representations in Inventor. So this is great. The advantage here is, of course, I could have done this directly in Inventor, but I'm not. One is I'm a layout designer and I'm very conversant with AutoCAD. I like to create layouts in 2D because that's very quick. So here we are leveraging your AutoCAD skill sets and giving you a tool that helps you to directly build your 3D rather than having to spend time in placing objects, assembling them together, and applying mates, constraints, a lot of those steps that are involved when we are creating a top-down assembly in a 3D modeling environment. As I said, this is a bidirectional workflow and we can do things in both directions. So here we are going to look at the same asset library that we saw in AutoCAD, and it is exactly the same library that you see in AutoCAD. So every object for which there is a representation in the AutoCAD library, there exists a 3D representation in the Inventor asset browser. So I'm going to look at the asset browser here, and you will see that it is exactly the same system assets, the same library, the same favorites, and my training folder, which I'm using for this particular presentation. And I'm going to now add objects that are not at the level of the floor and which are raised, which are at a certain level and away from the ground. For example, this seventh axis that I want to place on the top of this platform. Now, one is I can place this and use my 3D modeling commands to assemble and align them together. But with the factory design utilities, we provide a very interesting and intuitive workflow wherein you don't really have to spend time in those mundane tasks of putting things, assembling things together. You see these green dots at my asset and also at various places in our layout. These allow us to directly put together assets in the desired way. For example, I'm going to quickly connect the two assets, and you'll see that they are not just aligning them together, but the new asset that I placed was also resized according to my existing asset. So let's go ahead and place a few more assets. For example, I'm going to take this asset here, and the moment I start placing it, I see it can be aligned to various places out here. So for example, I have this asset placed here and maybe another one out here. And let's go on to complete this by placing a few conveyors. So I'm going to go to the system assets, and conveyor is something that I buy ready-made. I buy it from a conveyor supplier. I don't really manufacture conveyors myself. That's not my job. My job is to manufacture some automotive components. Okay, so I go to the conveyor library and locate my roller conveyors. That is the type of conveyor I want to use here. And if you are sort of okay, you may work in any orientation here, and I am good at working in AutoCAD, so I would rather look at a workflow that is similar to AutoCAD, and I am placing this object here, which is the conveyor. And just like in AutoCAD, I can snap. I'm pressing the control button on my keyboard and aligning or ensuring that my asset sticks to various grid points. Now, of course, I can use some of these tools to align, move, but that is where exactly I needed my asset. So I stop and I continue to place a curved asset because it's a conveyor, because it's something, the metal is not going to go in a straight line, but it is going to turn and move in a different direction. So again, I'm going to use this intelligent connection method and place the curved conveyor out here. I go on to continue to place my assets. Okay, I missed doing that, but let's do it again quickly and connect it out here. And just one more conveyor right here. So I got a set of conveyors placed and so on. Good for me. And yeah, I quickly placed my conveyor assets where I needed to place them, and got them correctly. But I placed something that was very standard, and maybe this is not the size that I wanted to use. Okay, so for example, I want to move this a little bit, so I can always say reposition and use these tools to move my objects. Also, now this is an asset which has perhaps some variant. So I'm going to go to this factory part here, and I see that there are multiple variants that are available to me. So I'm going to make it a double variant. I'm going to select the double variant, and since this is an intelligent object, it automatically I could change and vary it. I'm going to select this guy and obviously reposition them. They are essentially going inside the frame, making a few changes, because in 3D now I really know what is happening and how the assets are being done. Now this is of course repositioning asset variant, but here for the conveyor, I want to change the width of the conveyor. This is not the right width. And when I click on the conveyor here, and on the left hand side, I see a tab known as factory properties that tells me various parameters that can be changed in this conveyor. So I change it to maybe 40, and I just press enter on my keyboard and wait for the change to happen on that unit of the conveyor. But you'll quickly see that since we have a set of connected assets, the entire conveyor chain or the set of conveyor elements that are connected to this base asset are automatically modified and they take on the width. So I'm able to quickly make these changes, and this is my layout, very nice. But I have made changes to this and my AutoCAD drawing is not yet updated. So how do I manage this? As I said earlier, this is a bidirectional workflow, and I'm going to save this and say open in AutoCAD. So we are seeing things live, and the lag or any time that it is taking is the real time it would take in a real life scenario. So I'm not showing you a video, but just doing this exactly in front of you on software which is open on my machine. So it took a while and it converted the AutoCAD drawing with the representations of the newly placed objects. And the moment when I say save, this drawing is saved. And once this is done, let us go back to our master layout from where we had started. So I go to my master layout, and since this is an external reference, I can quickly update it and get a updated AutoCAD drawing. And this is, as I said, a pure AutoCAD drawing, which is as light as an AutoCAD drawing can be. There is no 3D representation out here, so no lag, no very high-end resource requirements here for opening and viewing and reviewing this drawing. So connected AutoCAD workflow, very nice, very good. I'm very happy with this, but this is not all. I want to now convey this to various stakeholders, and these stakeholders want to review my layout and really want to look at it from the perspective of a third person. Now, in the product design and manufacturing collection, we have another element or another tool, which is Navisworks. So I'm going to open up the window of Navisworks, and let me take you quickly to my desktop. Let me let me pause out here, and let me bring up Navisworks. Because there are so many windows open, I need to minimize a couple of them, and let me see how I can get to you quickly. So here we are. This is and let me open up my Navisworks window out here. So what you see on screen is the software Navisworks, which I have opened, and again, similar to the factory layout in Inventor, I see a floor out here. So what I'm going to do is I'm going to simply get my layout, the one that I just created, and get it out here. So let me locate the drawing, and the drawing that I created is that of a new cell, which is all out here. So this is the drawing. This is my new cell out here, and I'm going to bring it right in Inventor. So Navisworks is a tool of its kind where it can import data from any file format. So it is primarily used to bring together data formats from multiple tools in a single environment, because in a real life scenario, different people belonging to different domains, it could be structural, it could be piping, utilities, HVAC, everyone might be using different tools. And if I want to check for a clash between, for example, HVAC or refrigeration lines or ductwork and the structural part, and these are things that are being done by two different contractors, how do I do that? That is something that I can do in Navisworks. So this is a factory owner's tool for reviewing inputs from various stakeholders. Now I got this layout here. Again, another important part or feature of this Navisworks tool is it is very lightweight, and it can easily open, and we can review very large 3D models out here. It converts the data into a very lightweight format. But having said that, it is not a one-directional workflow, which means that if I make changes to this in my Inventor, I simply need to say refresh out here. So that is what I'm going to do now. I'm going to go back here and I'm going to add something known as the solid floor. So again, a solid floor I could have created by drawing a rectangle and extruding it and giving it a thickness. But I have a feature known as the solid floor. So I could directly place a solid floor below my layout to represent a real floor. Why I want to do that is because in Navisworks, I'm going to actually walk a third person on the floor. So here I don't see the floor yet. I just simply need to say refresh. And I got the floor. Now, okay, it looks good. What are the things that I can do here? As I told you, this is a design review tool. So I really want to walk on the floor, but I want to walk using a third person. So I have a third person out here. This third person can be changed to a different person. I can be office worker, he can be factory worker, he can be office lady, he can be various things. I can change him. But right now, let's get him to walk on the shop floor. So in order to walk on the floor, I need to enable gravity. So when I start walking, he directly falls to the floor and he stays there. So for example, if I did not have this floor beneath him, he would have gone straight down. But that's why I created the floor, and I'm looking at it, the floor from his perspective now. So we are walking now. He can walk in this. Why? Because he's not walking through, because I have elements of collision that are enabled. So if I switch off collision, I can really walk through. But that is not how I want to see it, because I want to figure out whether the gap between two machines is good enough for a person to walk through or enter. Okay, so I'm going to enable collision, and I'm going to review, and I'm going to switch off the third person. So now when I look at the factory, this is from the eye of that person. Okay, I can say look around. I'm now looking at objects from the height and perspective of a person who is standing in the shop floor. Great. But when it's a large factory and I want to show the same location again and again, I need not walk and use my mouse always to really figure that out. So I have an interesting way to do that. So I'm going to quickly switch off gravity. Let me now, I have to really go to that place and make him walk and go towards that. So it's a time consuming thing, and when it's my factory layout is large, I may sometimes find it difficult to really locate the place I want to show. So for that, for managing this, I have a capability known as the viewpoint. So I'm going to enable viewpoints. Let me first go to a specific location out here. Let me start a viewpoint, and maybe this is where I'm going to start. So I have viewpoints. I'm going to save my start viewpoint here. I'm going to this is fine, and I'm going to walk him to various places, and let's say I'm showing this is my second viewpoint. I add another viewpoint out here. I take him out here, add just one more out there. I can name my viewpoints the way I want it, change his direction, add a fourth one. Great, I can easily go to the start, go to the second one, go to the third one, go to the fourth one. But what if I want to quickly run him through these locations? I can right click and create an animation out here and drag and drop my viewpoints into the animation. So I click on the animation now, and I can say play the animation. I can go ahead and of course I can record this as an AVI file, share it with various stakeholders. Great. And good, it also has tools to do markup and review, because we are not just looking at it from the perspective of how good it looks, but we want to identify problems and also be able to mark them. So I have tools to do this, do a markup, write text, write comments, and so on. And the beauty is the viewer of Navisworks is absolutely free. It's called Navisworks Freedom. So I can share this file with stakeholders who need not have a software license to view this. They can view this in Navisworks Freedom. Now, this is good, but I want to do more. I want to show this in a very good looking way. So I can go to rendering. I can render this right here, which is good. I can create a nice looking rendering. So a very low quality, medium quality, high quality, whatever. I can start this and it will start rendering right on my machine. But if you have done rendering earlier, and I'm sure you know the time it takes to do physical rendering on a machine. It literally blocks your machine from doing anything else. So till the rendering is complete, my machine will not allow me to do the other things. So it is now starting to do the rendering. I have not placed lights and other stuff. So it will continue to do that till I say stop, and it will give me some image. So I'm just not going to complete it right now because this is going to take time. But what I can do next is I can render in the cloud. I can say, fine, I have placed all my assets, applied material, I have put lights and other things. I am now going to give it to the cloud to rendering, and it will go on to render in the cloud. I'm again not going to show you this because there is something more interesting I want to show you further. Okay, now this is good. I want to show a more realistic and interactive assembly. Here I am not able to interact, and this person who is moving like a straight robot. He is not a real person. So I'm going to show you the next best thing that you can do with this layout and spice it up a little bit. Now I'm going to export it with a file format known as FBX. Now, as mechanical engineers, we have been using MCAD software, which works with formats like STEP, Parasolid, and various other formats. But we have this format, which is the FBX. And this is something which I'm going to store in my layout, and I'm going to call it maybe layout. I can call it anything, just about anything. So I just did that. Why I did this and what is this FBX format? FBX format is a format that is used in gaming and in animation, and it can be taken in tools which can develop a game or that can create animations such as 3ds Max. And in this case, I'm going to show you the extension of 3ds Max, which is 3ds Max Interactive. So let me actually close this. I was doing something before we just started out here, and I'm not going to save this. I'm going to use something which is of a template. Now, one of the things that you might want to do, and I have heard customers say this, and really I have a few customers who are using this, and as a tool to design review, and not just something that you can review on the screen, but in a VR environment. So I have a template here. So if you create your layout using this desktop VR template, you can directly connect a VR device such as HTC Vive or Oculus to your machine and jump right in your layout in life size. But right now I don't have a VR device connected to my machine, so I'm going to show you another interesting template, which is the character template, and I'm going to create a new layout, and I'm going to save it exactly where I have my other layout. So I'm going to call it I'm going to call it the factory. So I'm going to create this layout, and I don't want to save everything that I was doing earlier. The tool that we are now looking at is Factory Design Interactive, and which is something that comes as a subscription benefit for 3ds Max, and as the product design and manufacturing collection also has 3ds Max inside it. Hence, you also get access to use the 3ds Max Interactive. Now, as the name suggests, it's an interactive tool, so you can really add a lot of interactions, and exactly the same way a lot of us play with 3D games. Okay, we interact with objects, we pick up objects, we run a car, we do racing with a car, a lot of things. There are a lot of interacting third-person games, and this is exactly what I'm going to do with my layout and make it more interesting to show it to all the stakeholders. So it'll take a minute or so to get started up, and we'll quickly come over to the layout. And the remaining part of my webinar is going to take another 10 to 15 odd minutes. So please bear with me, because I'm showing you things live and this is not a video. So hence, we are looking at things as they happen in real time. Oh, took a while, but there it is now. And well, it's a 3D software like any other software. So it has 3D objects and it has things that I can delete, remove. I can primarily not create here, but but bring in objects from other creation tools such as Inventor or any other 3D modeling tool or 3ds Max. I can create some elementary objects such as this plane, cone, and other stuff. But all this thing that you're looking at can come from other tools like 3ds Max, Navisworks, or Inventor. What I can do with this, I'm going to play this game, whatever it is. Okay, so I'm going to say I want to test this out. The moment I say test this game, I see a small nice window. I'm going to maximize it. And I see this character out here. I'm rotating my mouse, and with my gaming keys, we are familiar with the gaming keys, WASD. I'm moving him forward and he can go on top. He can really walk the stuff. But I want to do the same thing with my layout. So quickly going back, I don't need all this stuff out here. Just delete everything that is there. I am deleting things and removing all the objects that are there. Let me delete everything. In fact, let me delete out all the stuff. Okay. Rather, not all the stuff exactly, but yeah, fine. That's okay. I have a blank screen here. So I'm going to get my layout. And here below we see a folder structure which has a lot of things here. Okay, so I'm going to go to the model space and create a new folder which I'm going to call a layout. Okay. Go inside the layout, and on the left here I see a import button, and I'm going to import my layout object. And fine, great, it looks good. I simply say import, and I'm getting the objects imported into my folder, which is the layout folder out here. It's done, and I see this layout unit out here. What I can do is I can drag and drop it out here in my layout. So I got it. Great. Let's see if this works. Well, I'm testing it, and there is my character, and I see that he is not really on the ground. Why? Because I have not defined a few things. I want to give this guy, this floor, some physics. Okay, so I'm going to open this up. And when I open this up in something known as the unit editor, I see that I see the exact same assembly structure that I could see in Inventor. So I'm going to take this floor object, right click on it, and I'm going to say create a physics actor. Okay, so it defines some physics. It has mass, it has material, it has everything that a physical object should have. So I save it. Now let's try that again. Try that just once more. Yeah, now my guy is right on the floor. Let's maximize it. Oh, where's our layout? There it is. So I can really go and move to my layout. Now I can see inanimate objects out here. Okay, I think see objects that are not really moving. So in the interest of time, what I have done is I have created an animated object. Okay, animated object, and I'm going to import that very quickly, which is this guy called robot animation. And I'm going to say this animation has an animation associated to it. So I'm going to say import the animation as well, and just do it right there. So in the same layout, I just imported the animation. Fine. When I look at this object, I see it is something which looks like pink, so which means the material perhaps is not properly visible to me. So I'm going to apply a different material out here. By selecting this, I go to the material. I look out for some nice material. I don't know whether I have chrome. Oh, there it is. So I'm going to apply chrome. Okay, I'm going to apply chrome to this guy. And there it is. I have chrome applied. I save it. That's fine. And now I'm going to place this guy here. I can place it anywhere. Okay, so if you see, I have the same guy, same object placed on the floor. I can place it at a higher level as well. Okay, so this is my new object that I placed. Okay, very nice. But as I said, this is an animated object. I can add animations to it through Inventor and bring it here. Okay, so I've already done that, and I'm not a programmer. Okay, so I'm not a very big fan of coding. So in this software, I can do simple things like define what should happen with an object by simple connected boxes. For example, what is the data that I want to really get? Okay, so this is my unit, which is the unit I'm going to take. This is the unit. What do I want to do with it? I want to animate it. Okay, so I want to play some animation clip. How do I want to do it? I want to do it by pressing a keyboard on my button. So there's some input element, and I go on to say that I want to press a button on my keyboard. So these three things. Now, what is the animation clip? So I search for the animation clip because it came along with the object. It has the same name. Any changes to speed and other stuff? No, not required. But what is the button? Maybe I'm going to say I'm going to press the P on my keyboard. So I'm going to say this unit is going to be animated when I press the P button, and when it is released, I want to pause it. When it is held, I want to resume it, or maybe I just leave it at that. Very interesting and a simple way. I go back there. Now let's jump back to our game. In fact, let's test it again. I maximize it. Well, let me go and stand in front of this guy. Okay. I can also see from a third person. You can see that there are some shortcuts mentioned on the bottom of my screen, F2 and F3. With F3, I can do a fly through. If F2, I can do a walkthrough, and I press F2 again, it's a third person view. So I'm going to use the third person view, or maybe just look at it like this. And I'm going to press P. So if you see that as I have pressed my P button, because the way I have defined it, I can see the animation happening. So I can do very great things with this. I can have multiple such objects and say that after this has stopped, another object should start. So let me put this another guy here. Okay. And now when I click on this another guy here, it says that it is not robot animation, but it is robot animation 1. So I can go to my level flow. I can simply copy this guy, Control C and V, and I click on robot animation, but the unit is not robot animation, but robot animation 1. So this is the guy which is going to get played here, but when it has to play once this is paused. Okay, so when this is paused, I intend to play this other guy. So let's go back there, let's play it. Maximize. So I have two objects moving at different pace out here. Okay. Now, very interesting, I can really run a sequence of operations. I can have a button on my machine where I press it physically and I make the machine to start. And all this I could do by simple no coding experience. Okay. And of course, you get to know how these boxes can be connected, but it was pretty simple to understand. There's a lot of learning material available out there. And I simply brought in data which needs to be animated with a certain input. And as you see, I can give this output to Xbox or PS4 or just play it in a web browser. So this is a very great tool that can really spice up your layout and make it more lifelike. I can also output this layout to a VR device as well. So if I go to my deployer, let's look at the deployer out here. I can deploy it to various outputs. I can give it to Android, and I can give it to Android for Gear VR or a Google VR. I can give it to iOS or PS4 web as well as for Xbox. So this is, or even just for Windows, I can simply create a exe file. So I'm just going to do that right now. I'm going to create a very quick exe file for this thing, which I want to distribute it or give it to my colleagues who want to review this at their leisure. So I'm going to go just to that same folder and give it a name. Okay. And just say package for Windows. So it's creating a package output, which I can share it with a stakeholder, and he can play it without really having this software with him. I can do this in a limited way. This is not meant for publishing a commercial output out of the software, but I can share it with colleagues within my group. So maybe half a minute more and it will be through, and I'll show you the output, the way it looks and the way it can be invoked. I can write an output package for my mobile as well, for my Android device, and install a package on my Android device, and I can really use my touch controls on the Android to review the layout. So it's done. I go to the Windows Explorer window, and this PC, and this is the layout. This is my folder out here, and this is the exe file that was created. So when I double click it, it extracts into a folder and runs on its own. So there it is, and I can say start, and there you go. There's the game. Yes, I had not saved the entire layout, so it had the contents that were there earlier. So the thing that I need to do was save level and then run this entire program. So with this, let me take you back to our presentation. This is where I end, and uh, uh, what we really saw was a tool that allowed you to do process modeling. It allowed you to create a very compelling layout and create a very interesting interactive output. Okay, so sometimes you really want to explain how a machine works or how things are picked and placed in a factory, and the tool 3ds Max Interactive, which is part of the factory design utilities and the product design and manufacturing collection, just lets you do that without a lot of knowledge about animation and programming. So with this, uh, we move on to the next phase, wherein I would request my colleague to allow you to ask the polling question. So as we said earlier that we will have a set of polling questions towards the end, and this is the time now where I will put on the polling questions, and also request you to ask questions. Now you see the poll on your screen right now. Okay, so request you to all please answer these, and basis these we are going to do a lottery and announce winners. After you have done this, and after you have we have stopped the webinar for the day, you will be receiving a mail as well, wherein we will request kind feedback from your side to as to whether the contents were relevant, and how whether you want a more detailed explanation of some of the workflows that were shown in today's webinar. So we would be happy to do something again for you based on your feedback. As you are doing out or filling out the questions, I would also request you all to interact with me in your chat window. Please do ask me questions via the chat window. You will see a chat window next to the go-to meeting panel, in the go-to meeting panel, and request you to use the same to start asking or posing me questions, and I can quickly give you some answers to that. Well, there are 4 questions, I believe, and this is the third one on the screen, and request you to fill all of them. so we really know what worked and what needs to be improved. So a couple of questions that I'm already getting is, someone asked me here that the asset libraries that I'm looking at here, do I need to model everything in this software, because my design team uses a different 3D modeling tool, and I usually take their help to model the 3D assets. So the answer to your question is that the assets for the factory design utilities can come from any 3D modeling software, as in a non-Autodesk software. It can come in from other professional tools such as SolidWorks, Solid Edge, Pro Engineer, CATIA, or Unigraphics. And not just that, we can use some good capabilities in the PDMC, just such as Recap, wherein we can create layouts using a scanner or just your camera by capturing multiple photographs of your asset on the shop floor and stitching them together to get a 3D model. So that workflow is something that is also supported in factory design. So it's not that you have to model everything. You can use photogrammetry or laser scanning to bring in assets to the factory asset library as well. Another question here is, my company uses a factory simulation tool, and I really, although it does very good simulation, I find it challenging to create the layout in the first place. So can data from your solution go to a third party tool for advanced factory simulation? Yes, absolutely. We can write out various file formats from the factory design utilities to be consumed in uh, other tools, which perhaps might be very relevant to your workflow. And yes, we can do that. One last question here is what I'm going to take, and the question is more to do with beautification of the layout. Can I show the effect of smoke, fire, water, people moving in my layout? Absolutely, you can do that. Why and how you can do that is because we have 3ds Max and 3ds Max Interactive right inside the package, and you can use them to do a detailed, highly rendered walkthrough with the effect of smoke, water, fire, and so on. So guys, thank you for attending today's webinar. It was really a pleasure to be showing the workflows live here, and hope to receive your feedback so that we can plan for similar sessions going ahead. So with this, I'm going to end my session. Thank you all for joining today.